You've heard of Bitcoin. Maybe you even bought some. You wanted to learn more. Still lost. This is the first video in a series to help you break through and understand what it's all about. In this video, I'll be talking about how transactions are recorded. We will cover 3 different methods: proof of work, proof of stake, and proof of research. Along the way, I'll discuss some of the implications of each method. Bob wants to send money to Sally. Traditionally, this requires a third party. Bob tells the bank he wants to move his money to Sally's account. The bank records the transaction, and now the money's under Sally's control. Bob no longer has control and can't spend the money again, or double spend it somewhere else. In this payment model, the bank is the keeper of the ledger. Both parties trust the bank. Well, most of the time, but that's a whole different topic. What if you wanted to eliminate the bank? How would you know Bob moved money from his account to Sally's account? Bitcoin uses a public ledger, commonly referred to as the blockchain. This ledger is kept by everyone. Each computer on the network, commonly referred to as a node, has a copy of the ledger. Bitcoin eliminates the bank. Now you know why banks don't like Bitcoin. Now that you understand how the blockchain works in relation to traditional banking, let's talk about how transactions are recorded. When Bob sends Sally Bitcoin, the transaction is broadcast to the entire system. This transaction is then grouped together with other transactions into a block. To incentivize the collection and recording of these transactions, the network rewards the one recording the block with Bitcoin. Everyone is competing for the right to record the transactions, but only one node on the network can make the official record at a time. How the network decides who gets the right to do this is determined by a set of rules. Bitcoin, and many other coins, use proof of work to determine who gets the right to record transactions. Basically, computers on a network work as fast as they can to get the answer to a complicated math problem. The computer that solves the problem first gets to record the transaction and receives the rewards. Proof of work is kind of like a race. The first to the finish line wins. When a new block is found, the race starts all over again. If you want to win, you need the fastest computer. When others learn about the network and want to get in on the rewards, they connect. The faster the entire network becomes, be it through more connections or faster machines, the faster the math problem is solved. Without making a problem harder, it would be solved at an ever-increasing pace. To prevent that from happening, the difficulty of a problem is increased to target a set amount of time between when blocks are found. In the early days of Bitcoin, the difficulty was low enough the problems could be solved with simple computers. More connections to the network meant the blockchain was more secure from attack. Over time, the computers used to solve these problems became more specialized, and operators began to pool resources to make solving a block more likely. As equipment has become more specialized and pools have become larger, the number of connections has begun to fall, making the network less secure than it has been in the past. Going back to where we were on our payment example, we now have a winner, and that winner will keep the block reward and record transactions on the public ledger. The Bitcoin Bob sent Sally is now under Sally's control, and Bob can't spend it again. Proof of work has been criticized for consuming massive amounts of electricity and producing mostly just heat. This is because most of the work done is discarded when a new block is found. It has no use. There have been several solutions proposed to make this work useful. One of the more notable examples is Primecoin, which changed proof of work rules so that the problem being solved was searching for new prime numbers. Primecoin is a great proof of concept, but the downside is that it has a very limited application. Another approach to lowering the energy consumed was to change how the network decided who would sign the next block to an algorithm that relied on something besides computational difficulty. This method, called proof of stake, lowered the energy consumed by using coin ownership as a factor to determine who would sign the next block. Purecoin and Blackcoin are 2 notable coins who have employed this method. If proof of work is like a race, proof of stake is like a queue or line where everybody gets their turn. This payment system uses a combination of randomization and a concept called coinage. It is a low energy approach, and your place in line and probability of signing the next block is typically determined by how long it has been since you were last paid and how much you are owed. The reward is typically interest, kind of like on a savings account balance. Proof of stake lowered the energy requirements, but what about all the computers sitting idle? Proof of research came out of the desire to solve real-world problems. But to understand it, you have to know a little about BOINC. BOINC is an open-source distributed compute wrapper that anyone can use. It allows people to contribute to a massive supercomputer network while their computer is idle. Universities and institutions have used it for more than 10 years. Projects cover a large swath of mathematics and scientific inquiry, from mapping the Milky Way and modeling climate change to folding proteins in search of cures to diseases. Regular citizens are able to contribute to these projects with their home computer. Because of the diversity of hardware and platforms supported, projects are only limited by their creators' creativity. There's even a project where you can search for extraterrestrial intelligence. That's right, you can look for ET. Boeing was all volunteer prior to Gridcoin. Proof of research is a way to compensate volunteers for the work they do on their computers for science. It's a method that combines a useful proof of work and proof of stake. When a node, or in this case, researcher, does work for a project, their work is measured and they are given credits. These credits are averaged over time, with the most recent credits having larger weight than the credits received in the past. This calculation is called a recent average credit, or RAC. Maximizing RAC can take up to a month. Proof of research was developed by Gridcoin. When this video was recorded, Gridcoin was the only cryptocurrency using the proof of research system. At the time, there were 37 projects on the approved list. Different projects use different types of hardware. Some use CPU, some GPU. There are even projects that use your Android phone or support Raspberry Pi. Each project's different, and you can choose projects that best fit your equipment. Each project receives its share of the total Gridcoin created in a day. With 37 projects, 1/37th of the total Gridcoin created in a day is allocated to each project. Your contributions to a project are measured against other researchers. This allows for the flexibility of any type of compute resource while not overemphasizing a certain project or hardware type. Each researcher's contribution share is added to what they are owed. Much like coinage in proof of stake, in proof of research, the node that receives the reward is determined by a combination of how much is owed and how long it has been since they were last paid. This is called research age. In many ways, this is similar to a pay-per-share pool. As I mentioned, it can take up to a month to maximize your recent average credit, and you can accrue rewards for up to 6 months, so even the little guys get paid. If proof of work is a race, and proof of stake is a queue, proof of research is a marathon that never ends. You aren't paid for being the first one to the finish line. You're paid for all the work you've done between each checkpoint. Researchers on the Gridcoin network are doing real work and helping scientists solve some of humanity's biggest problems every day. Why mine when you can research? Learn more at gridcoin.us.